So hi everyone, I think we are live. Let me check it. Oops. Business. Let me. All right, so hi guys, hi folks. Good morning, good evening, whatever. So this is the continuation of course day 7 and our entire series. We're building for the folks who are very new here. This is day 8. We're building a production RAG system that supports 85,000 rocket science documents, from scanned copies from 1950s to handwritten notes from 1960s to documents till date. Those documents are quite complex. They have a lot of graphs, you know, technical diagrams, mathematical equations, formulas, and etc. So our goal was to build a production track system that works for 85,000 documents and also be able to, ingest documents at scale. So we are working currently with 10K documents, and it can easily support 10K documents. And we're currently working with a 10K document space. Also, this, but with the goal of designing it to work. Because with the goal of designing the entire component to work for 100,000 documents, right? Even more. So if you were to work for a 10K and pull it off, 85K is actually in for a problem, right? And yeah, and of course we have all of our thesis and etc. We'll go through them, but yeah, let me quickly go through what we a quick rundown on what we're trying to do. And all of those stuff. So we are building a project for a simulated company called Meridian Aerospace. There's a consult engineering space agent. They work with space agents. For example, they partner with NASA and etc. Of course, this is a fictional company, but very sort of a true scenario. And they have 85,000 documents with proportional test reports, safety analysis, 19 from 1990s actually. But our test data, we were able to pull it from NTRS from 1954. So one of our oldest documents is actually from 1954. So just to give you guys a quick visualization on the sort of documents we work with, you can see over here, this is actually from 1954, and you can see the amount of info that is available. And we've done a lot of metadata extraction symbols, and that was a complex part. We did it for the entire 3 days, and you should be able to check it, part 1, part 2, and part 3. Do check it out. And it was like a couple of hour like a long hour live stream. And yeah, they have a lot of scanned copies, heavy use of technical jargon, domain specific acronyms. We're going to solve that today or tomorrow. We're going to pull in 3,000 to 4,000 domain specific terminologies from NASA thesaurus. So let me quickly pull up thesaurus. Yeah, oops, not this. And yeah, NASA thesaurus, they give us access to free 18,000 vocabs. We are going to only use it, and this includes like biological, biosciences, earth sciences, planetary sciences, physics, and etc. But we're only going to focus on rocket science stuff. So yeah, we'll only be using the 3,000 to 4,000 samples, and we are not going to fine tune a model. We are not going to do it. So we split on two. First, we have a document processing that works for at scale. Um, that is entirely using open source models. So for example, Qwen, we're using Qwen for it, and that's what we're going to continue today. And second is the agent. I'm using Claude. You can in an actual environment you can use any sort of model you want, really. So I just wanted to split that up. And but entire embeddings and everything, it's totally using Ollama. And Ollama, which is like, oh, sorry, Qwen and etc. I'll show you in a bit. Yeah. So that's what we're gonna continue. We stopped it yesterday halfway. I had to run out, but today I'm just gonna quickly go through and just just kick things off and just try to figure this out. So yeah, uh, yeah, cool. So we'll get it out there. Now we had a small issue with yesterday we had a small, actually small issue, such a damn issue with our CUDA environment, and then VLLM, and it was crashing for some reason. I wanted to use VLLM. Yeah, just a minute. I wanted to use VLLM for deploying the model and loading and everything, but seems like there's a lot of CUDA issues. There's a lot of big. I'm using Azure. Some of the packages are very old, and yeah, it's just messed up. And I can't restart I can't delete the container and then adjust it because I only have like a specified quota for it. So I'm just worried in case I would because I'm currently renting an H100 through Azure. I have it, so it's a 96 GB variant, and that's what we're going to process it. And just to take a look at a plan, H100 plan, ingestion config. What we're going to do, we're going to use this specific model for VLM, and this is entirely on H100. So you're going to learn, you probably would see how you could deploy this on an H100 and process 10,000 documents really at scale. There's a lot of things that could go wrong in terms of parallel processing, concurrent embeddings, and etc. So we have done a lot of work. Yesterday we spent a lot of time planning this out, and I would highly encourage you to do it. But I'll just quickly go through. This is my hardware spec. I have a 96 GB NVIDIA provided through Azure, and system RAM is 314. The final configuration, we're going to process 24 documents in a single queue and in a single batch also, like in a single given moment, and VLM workers per doc, meaning that 24 docs, and each of the 24 docs will have parallelization, meaning, for example, there'll be a pipeline for tables extraction, there'll be a pipeline for image extraction, there'll be a pipeline for formula extraction, there'll be pipeline for figures extraction, and etc, chunking, etc. So that would internally have 3 maximum workers. So total current VLM will be 72, and an embedding batch size is actually 128, meaning I could process, give it a shot for 120 embeddings to save it. So here we have model weights and all of them, which is only 33 GB, and then you need KV cache, you need 58 GB for concurrency, because of course you need to manage 72 requests, right? Concurrent VLM requests in a given moment. So that's why we have this 58 GB. For embedding only we have 5 GB, and then for VLM we have 33 GB. Okay. So yeah, this is just a math. We spent a lot of time, trying to find the optimal spot, and yeah, per document we see it to be 67 seconds, but I think it'll definitely be more than a minute. Like it'll definitely be a little bit more than a minute. Ingestion, and yeah, all of this, and yeah, these are like basic stuff. That's the overall idea of it. And we actually planned, if I were to scroll up, we actually planned to use uh the model through VLLM, but we just dealing with a lot of CUDA issues and etc. I just don't want to spend time to it. I'm going to fall back to Ollama with the Q80 version, which is nearly, if you go back here and you can see, the quality is nearly 95 to 97% versus FPS 99%. There's only 2% difference, and Ollama provides all the API, and it's very easy to sort of deploy it. So we'll fall back to that. So yeah, that's what going on. That is the current progress sort of. We've already built the UI. We just today we are goal is to process all the 10K, just run it over, just sort of put it, just expose all the API, and then ingest all the 10,000 documents. I have the list of 10,000 documents quickly. Let's see. Uh, it's in my SSH machine. Actually, I had it in a different machine yesterday, and I merged it, my data drive to a different disk with the model inference. I guess 13 point something. Yeah, this one. My password. And you can see, oops, CD. Meridian. And you can see we have 10,414 docs pulled from NASA. I leave the code that I ran overnight. It should actually took me 7 hours to download with all the API rate limits and etc. And you can freely get it from the NASA's technical report server. You can even get the maximum amount of document. There is no cap for it, but you have request limits, and it's entirely free as well. So kudos to NASA. Thank you so much. Even thanks for the help on Thesaurus as well. Okay, so very good. So we're gonna fall back to Ollama, but then we're gonna still get 99% accuracy here. So like All right, let's fall back to Ollama. And yeah, so I think this will take, once we complete this, probably take at least 8 hours to process all the 10K docs, stay with us embeddings, and do all of the because there's a lot of metadata extraction and whatnot. So in fact, I want to visually show it to you in a bit how our document processing is sort of is designed, and I'm going to show how, why it takes a lot of time. 8 hours is pretty good, I would say. For a work like this, it's quite decent, I would say. Cool. This is some cleanup commands because I've used VLLM and etc. So I'm just gonna go quickly do some cleanup. No, actually, what I'll do, I'll pull it from VS Code itself. Connect. Oops. Oh, that was fast. Shit, this is the IP. Oops. Oh no no. Oh, it's my use my username. Sorry about that. All right, so we are inside. Let's go inside the folder and do the cleanup, and we do Ollama and yeah, cool thing. No, actually, not this. What's the difference? Connect to the public IP. We've copied all the necessary documents to deploy, and this is this is an H100, right? I'm sure. Yeah. And because I couldn't afford it to rent through RunPod, it'll probably cost me $700 a day. So this for in Azure, I get it for 5,000 for the entire month. And of course, I'll delete it once I'm done with it. Cool. We'll do a cleanup first. So just to, if anyone is watching and sort of very new here, not new, I probably explained you, but this is a continuation of yesterday's, progress on processing most of the documents. And we hit a roadblock with, not a roadblock, just CUDA version issue and etc. I don't want to spend another five hours debugging that. And Ollama gives you the Q8 version for 95 to 97% accuracy. It's not a big bump. It's not a, yeah, it's not a huge bump. So yeah, download. Actually, you wouldn't need this for all. Yeah. Can't I pull it directly from Ollama? One, go Ollama. But will it give the specific version? I think so. Yeah. Yeah. Yes. We need instruct version, but this is okay. A good catch. Ollama pull gives you quantized 4, not 8. That's the thing. Check available tags for or look up. If CUDA exists, you'll need to manually download the Q8 quality. The difference is Q4 99%. Q8 will be for document processing. Q8 is better. You call speed 4, quality 8. I would say let's go with 8. Manually download it. If I manually download it, could I still run it from Ollama? Okay, so we're registering the model and running it. Okay, let's give it a shot. If not, we're just, falling back to Consul S4, but I want to run the Q8 version. Uh, yeah. The reason why we want to run on an H100 in a production use case, that's what I will do, because H100 is designed to run on FP8 floating points instead of the integers. Usually if it's a production, I'll spend like a day or two just in fixing the issues and doing all the CUDA stuff, because that's very important trying to choose. But for this, totally focused on that. As long as we get like 95%, 98% accuracy, it's just the same thing. And yeah, so we'll give it a shot. We're gonna download this model. To one commands. Okay, start. Okay, so let it download. Download Vision projector. Create the model file. Test it. Okay. Actually, we have the thinking concise 8 version in Ollama, but we don't want to get thinking because you can't control thinking. And of course, you can prompt to the Qwen models. Unlike any other Claude or OpenAI models, you can't have direct control. If you were to reason a lot, if you think it's a hard problem to solve, we'll just keep on reasoning. And what will happen is that even if we spend 20 or 30 seconds or maybe even a minute extra for a single document, 8 hour per document processing would actually go jump to 15 hours to 16 hours. So in case if I were to complete this in 4 hours, the next 4 hours, assuming we can complete everything, I'll put it up and running, and we'll only be able to access it tomorrow this time. By the time we can work with the current agent, with the few thousand docs or whatever. And yeah, but entirely once connected to the 10K docs, we'll only be able to test it, like I'm estimating, like tomorrow this time, which is the day nine service stream. So yeah, but yeah, you could still use it, but I don't want to still like doubling the amount of per document processing. And also you would have like parallel workers inside as well. For example, if I were to show the diagram, we have VLM, we have Ollama, and we will do the ingestion parallelly for 24. And even if each sort of takes, I think the estimate right now is 67 seconds for a single this thing, for a single doc. And if you were to even double this up, it'll become at least add 5 to 6 hours of time. And when you add 5 to 6 hours of time, there's also a good scenario where things could go wrong and you need to reprocess stuff. So you just have to find a sweet spot, and just not, it's not intelligent, it it's not how can I put it? Yeah, for document processing, using a VLM itself is like an accurate way of doing things. And I think this is more than enough. I would recommend people, like, if you were to do production deployment, you have to spend, like, properly with the GPUs and all the drivers and VLLMs and etc. You probably need a lot of time to do it. Take it, like, definitely. There is no simple way of doing it. Like, you need to get that time right, because you will have very different versions of PyTorch, you'll have different versions of transformers, you also have different versions of VLLM. You need to find the compatibility. Some of the models, recent models, will follow a different package. You have to write wrappers to it and etc. So we did, write a few wrappers here and there, but yeah, hopefully if this works, then fine. If not, we have to jump back to the Q4 version. Yeah, the thing is, we also have um a little bit of extra KV cache as well. This was 56. I guess the above FB8 was 58. So this will actually give us a little bit more RAM VRAM space, but we're not going to increase it. We're not going to reconsider the math and all. Just keep it as it is. It is just it's just giving us a little bit of extra buffer in case something spikes up, which could, you would never know, because you can, even though you get all your math right, you have your GPU stuff, everything, you would never know what processing fails or what could take more MB, because we're capping the, what do you call it, if you're capping the context, you cap the context for only 10,000, meaning even in images, if you put two 1080p images, that will only cost you less than 3,000 tokens. So the cap is 10,000. Yeah, as because you have a cap, we can like be fair enough that the GPU will not run out of memory and sort of crash in the middle. But because we also have 2 GB to, not 2 to 3 GB of buffer as well. But that's not only VRAM. You also want to consider your current RAM as well. If you're loading models, like, layout detection models, those will be loaded in your RAM. I don't want to put that in your listing, so we are loading it in our current RAM. That's more than enough because it's less than 2 GB. And yeah, concurrent embedding badge, you also want to allocate for embeddings as well and all of those stuff. So yeah, giving us a number of 1250 documents an hour and 8 hours of 10K docs. VRAM utilization is 90%, so we have 10% buffer. That's the safety criteria we're going for. But you can still push it for even 99 5 point. You can push it for 99% if you get everything right. If you manage all the drivers, if you literally have built queues for retries and etc. in case things go wrong, and if you use VLLM for dynamic caching and etc., you can easily push it to 99%. I guess a lot of companies will of course too, because that's the only reason. Because you pay for each hour, and if you were to keep that 10% buffer, it'll add up to this hour, right? Probably spend like, it will cost you another 1 hour, $3 or $4, or maybe $5. If you're renting a lot of GPU, then I don't know, easily more than $50 if you're renting a lot of GPUs and etc. So then always companies, the main aim is to squish this, but what do you call this? What do you call this? Squash? The minimize for the squash and so on. Squeeze. Oh, sorry. Yeah, squeeze. I'm sorry. Very bad English. Yeah, so you try to squeeze all of the memory, the compute you have to be able to run it accurately. And also, it's also another one thing is that um, once you do all of this stuff, you have another load of managing the model itself to do queries. In case you're working on an on-prem system, like what I do, I build a lot of on-prem stuff. Then you would use all of your models, you would use all of the compute that's available in order to host your model, and there's another set of work to do. So, and plus, even when you like, you will only know for document processing, it's okay. No one is actually using it when you process, so it's okay. But when you have actually users using the platform, you can't allocate for spikes, right? For example, let's say today I'm using it, and then tomorrow there's other 5 people using the company, and then some other company, some other day, like 7 people are using it, 10 people using it. You would never know. So that's when VLLM will make sure that you get the full juice, is because it'll dynamically allocate the context. Because here you're loading the entire 10K, you're holding the RAM, even though you use 3K, you're holding RAM for 10K, VRAM for 10K, not the other RAM. But if you was to use VLLM, what happens is that you could actually, if you're only doing for 3K, we'll only use 3 to 4K dynamic and free up the 7K of this thing. It comes with a little bit of cons, but gives you the optimal performance. Stuff like that. It's all sort of like a decision making sort of thing, depending on the company. So yeah, yeah. All right. So I think the model is downloaded. Yeah, I was actually ranting until the model was waiting until the model was there. So we'll download this vision projector as well. I think this is for images. Done. Right, we'll create the model file. Ollama create. So this is not provided by Ollama, right? We're using it from Hugging Face, but then we are adding it to Ollama. We're creating a model file and adding it to Ollama. Ollama doesn't provide this. I guess it's, let me see. This is my first time. I would directly do Ollama. I would directly do VLM. I've never tried this. So I just wanted to improvise on things. That's the thing. Oh shit, no. It's actually there's a download version. Oops. Yeah, you can mix precision levels for language and vision components based on your hardware and performance. Even perform quantization starting from FP16 weights. Oh, then I think this will also give you if starting from FP16, not okay, not 8. Yeah. Okay, success. Cool. Yeah. So the thing is, you can dynamically allocate stuff depending on the use. If you're processing more on the language side, which only using text and stuff, you can give more precision to that. And vision, I guess, starts with Q8 and FP16. And I would say a lot of companies would jump to even FP8 would actually have the compute to use FP16. Slightly bit of RAM, but gives you the full model performance. Like whoever, because open source models are so tricky, you just have to get the entire intelligence. Like even that 1 to 2% of intelligence, you would need to squeeze it up. So you would try to use you not full precision. You don't want to do like fully, but depending on if you might have an old A100 and H100, you want to do like an FPA. It depends. So depends on hardware by hardware. That's how we do it. Yeah, it's all like trial and error. You just have to understand it first and do like, just go back to Claude and just dump all of your thoughts and start asking questions. Why is this not working? Why shouldn't we do this? And why would we not work on why would we literally not work on FP8 on an A1, and then what's the issue? Could we write wrappers around it and etc. Because actually, when you see in companies, they have a limited amount of compute, and they serve users. These are consumer companies as well, not sometimes enterprises. They want to extract everything as much as possible. So you try to like so you would try to go very low level in terms of hardware, in terms of drivers, in terms of model wrappers and etc. That will actually try to give you a lot of bumps. And RAM usage, state, and removing dynamically allocating KB cache and etc. Yeah, those are stuff itself. So I want to cover that. I want to that will be some other tutorial, where probably not tutorial, like a stream. I just want to cover the entire different aspects. How would you like, given a very small compute, how could you manage a model of this size, and not just manage a model of this size, but also in our case, handle consumers. Let's say you're working with a consumer app, and you have 100 users, 200 users. How do you manage it, and how do you distribute loads? How do you put it on a queue and etc. Stuff like that. So that's entirely on a GPU front. I'll probably spend some time later to do it. So as usual, this is giving an error. Let's send it back. I think we need to run Ollama. It's already running. Please put the commands to the file, because I'm copying it from the terminal, is giving extra white spaces. I'm not sure if this is the limitation. Please check the docs link I've sent you. Use a subagent to do research, just understand everything and give you back. So this will save some context. Anyway, it's gonna do an auto compact, so it's okay. It can't be like this. I think we'll go with Llama CP. Whenever used it, I've only used Ollama or maybe VLLM. Yeah, we'll try this. Is this fast compared to Ollama? I have a H100, so will it use the max potential of it? Actually, actually, I've come to a conclusion that we have a H100 and we want to use its max potential by doing FP8, and that's what it's built for. Uh, so I think I'm gonna spend a couple of hours doing it. I guess it's fine. I think that's the right way of doing it, because that's what, like, using the entire, because I want to show it to you guys as well. Taking the easy route is it's not ideal. So we'll just figure it out. We'll just see what we can do. They seems to have a Docker file and etc. and send all the docs in Intraplex. I guess we have to be fixed with VLLM and using FP8, and so that's one of the reasons, advantages of really using H100 here, and that's why it's built for. I'm gonna say here are the docs. I know we not have what we should definitely. Tama. Ah, okay, okay. Sure. Did you check both the docs? Were you able to read it? Okay, this has stupid issues with all of this. Uh, yeah, all of this, what kind of UI shit. What I will do here is that I will copy all of this. To this. So what I will do here. File and this docs. Okay, I think it's truncated. Just send it like this. You know what? All right, just to give you some context, this is the file we are following. It has recent. Just to give you some context, this is what we were working on. We had some issues, so we went with Ollama for the model deployment, but I, but I think I just realized that we need to use the full H100 capabilities, and we need to be able to deploy this on an FP28. So I think it's very important we get VLLM for this. And what I'll do is just save this. It actually has context 7, guys. But in both of this be very helpful context. So I'll just pass this out. Just save it for now. Just save it here. I'll reference this image. Qwen usage guide. I think we have CUDA 11. Yeah, 11.5. Not 13 actually. I don't know how this 13 number came about. Okay, we'll download the CUDA version to 12.9. That's VLM's default CUDA installation. So once we do it, I think we should be in good spot. Let's see. Okay. About Oops, yeah, we run this. Alright, so we have come across an error. If we skip multi-model profiling, what's could we still process images? What's the loss? Do we have any loss? Yeah, only if we start large images at once, but maximum it's only 2 images and not even 1080p. Yeah, try this. Okay, just update the commands with this. Okay, an error. But this will definitely have 10 to 20% loss in performance, right? I'm talking about performance as a whole. Yeah, yeah, so I think there was a pre-built version with Docker or something, right? I shared it in the docs. That that probably would be the best way to go about it, right? Because it's everything is compliant, it's using Docker, so we should be fine, right? Yeah, if it's everything is compiled and if there's a Docker, then we're in safe hands. I can see GPU vendor specifications, NVIDIA CUDA, and this is a ranked version. There's something on Docker in that. Yeah. If you have trouble using VLLM, we recommend using NVIDIA PyTorch Docker image. We'll try this. We'll try Docker, it should be very simple. I think it'll take a while to deploy. Run this is extracting. Okay, alright guys, so it's running. Nice. Thank God. Now we can use FP6. Just go with speed with the hopper. Alright. Transfer to VM. I think we've already done this transfer part. Yeah, we'll do a curl and test it out. In fact, we can actually do a curl outside the terminal. So this is my okay, 20, just 13 point. I've exposed certain routes. I guess I was exposed only 8.8. I get exposed in Azure. If I see it's only exposed to port 8.8. We can just try it locally for now. Yeah, later I can expose the routes. Yeah, so you can see it's working. No, we don't need that change. Sorry, please make the change. system models we have. You can see we have VL32B instruct version. By default, we have 10,000 context. Nice, nice. All right, so this is working. Now code deployment, local machine, we have mostly we have all of this, I think. So I think this is giving us a command to copy everything, but we don't need everything. Actually, I don't need to transfer all of the code. This is agents and stuff. You only needed to transfer like the processing code only, and I already have this. I just need to update this bit because like data, API, all of them is not needed at all. We just need the extracted pipeline, the extractors, the embedding models. Oh wait, I think yeah, we don't need the API as well. There's no need for the API. Let's sync that. Okay. We have all the updated files along with the usage document. Cool. Now just install Python debugging series. Configure environment. And create an env file. localhost 63 because we're using 63 local quadrant. Locally for the VM it's local, right? And update config for H1. Like numbers of workers 3. 3 tries is okay. Max workers is also 3. So API URL model is this specific one. Max workers is 3. See how we call the model. And model keywords is Qwen dash Intraplex. So exactly the same thing. Embedding model is the same code. Okay. I think embedding model will be the same. Same thing for batch. Okay, embedding batch size will increase. Increase to 128. And column collection is Meridian 10K. Phase for verification pre-flight. I've completed this. Now I think we have to, I think we already have, now it should be phase 4. I think we already have the files created. We just have to run them. You see, we have verified script just to see, verify everything is working. You have the GPU, you have the service, have the, not Ollama model. I think that has to be updated. Yeah, should those scripts be updated? Can you just go through all the scripts and see if they have to be updated? Because right now we're using Docker. I mean Docker VLLM for model deployments. One failed and one warning. Corinth has failed. Yeah, because we didn't start Corinth. I think. Then I think we have to run start services, but it's okay. We'll just send this and see. Data disk H44. One input PDF zero, only zero PDFs. Oh, PDF. We have 10,000 PDFs. And change the part for the PDF, then we should say 10,000. And we'll resync it. The code. Oops. Code. Resync the code. Okay. Okay, now you can see results okay, ready to start ingestion. So this is a pre-flight check. We check if Qdrant is running. Ollama is running. Ollama embedding model found the specific model. VLLM server running. VLLM model is founded. GPU 895 96 GB to be on around 95 gigs of H100 NVL. There's also XSM I think, but I'm using the NVL version. Not a huge difference. It's still an H100. No, I don't think XSM is. Yeah. It's see the difference between them. Offers yeah, it offers, and also you can see run pod prices for XSM is much more higher than NLM. Power speed. Yeah, NVLM is mostly considered for larger model inference and reverse systems. Okay, cool. And we're doing inference here, so I think we are basically doing like a production grade, NVL system here. We did all the CUDA drivers. Right now, we're also managing the load and etc. That's what we're working on next. Pre-flight pre-flight verification is success. Now we have to try the injection. I think yeah, this is good. Looks good. What's next? Now I don't wanna if everything is good, I probably wanna no, I think we have a command for starting services. So here then why do we have start services command? When do we use it? I guess seems like the services are already running, or would we want to do start services and then start ingestion? Yeah, we have VLM, everything is running. So the thing is I want to test that. Yeah, so I wanna kill all the services and then use start services to run back everything. So I just want to verify if the command itself is proper, because later on you'll probably wanna make sure when you restart the PC or restart the VM, you should be able to run it properly. So we'll stop it and run this back again. I think we have to make it. I think we need to make it executable first. Okay, make executable. I'm not sure the full part. Yeah. Executable. Okay, it says Qdrant disrupt, but I can still see the VLM server. Docker. Yeah. I don't think all the services are stopped. I can still see Docker for VLLM is running. Yeah, now we'll probably use this image name and then force Docker to quit it. But this should be part of the stop command. But this should be part of the stop command. But this should be part of the stop command, right? Ollama is not running. Oh yeah, oh, okay, wait, I'm confused. Ollama is running, okay. VLM is not running, that's what we wanted. Actually, I like to manually start it. So I can see all the logs. I can connect to it, but I can see the logs. Although I think this is okay. But I want to manually start it. The VLLM. Good. Just the same. VLLM is already started. Should I run start services to run back embedding models in Ollama and Ollama and what's that? Qdrant? Okay, we have Qdrant started. Ollama is already running. Embedding model is loaded. VLM is already running. Status looks good for all of this. From verification, yes, we'll run a quick verification and see. This all looks good. Good for ingestion. This is monitor progress. So to click on this, it gives me a progress bar with all the monitoring stuff. I'll actually open this up in a different, put it over here, Control C to access. Okay. Oops. Cool. And I think everything is started. So I'll send a quick status. Set up. I guess everything is ready. Yeah, before we move on, I want to let you know that I want to process one single document and see if everything is working, or maybe two documents, or maybe we'll just put three documents because we can do it for now. And I also want you to give me a visual diagram of how our document processing is happening with all the parallelization and also the sub processes of tables and etc. So I want to show the viewers of how we're doing it visually before we move on to the ingestion. If there's any nuances, feel free to include them in the diagram as well. Diagram or the visual, whatever. Yeah, I want to quickly show it to you guys how are we doing the ingestion, what are we doing, because I'm pretty sure that, because I have everything in mind and I've been doing this for a while here in probably the ninth stream. I have a lot of context, but people who are joining or seeing would have no context. So I want to just show you what we're trying to do. And that exact process is now going to happen in a GPU. Now you can exactly clone this process even when you have the code to push it on a system. And this is like a production gate use case as well. And you just have to, I mean, of course, you need to plan out things. I mean, it depends on how many, parallel workers you want to run, how much of data you want to do, but I'll get into what I mean by parallel and what I mean by managing memory for certain use cases once I have the diagram, once I have the visual. All right, so in the diagram, let me quickly go through this. We have an H100 and GB one. We have 10,414 pulled from NASA's technical archive documents from NTRS. We have a vector DB, which is 124 dimensions, going to process in KDocs, and parallel processing, we're going to do it for 24 workers in a given time. We have a thread pool. Worker 1 will do the Dockling parsing, worker 2 will do Dockling parsing. So assume we're going to do 24 of this. And single processing will have this queue. You have the PDF, Dockling, CPU based, and loading everything for the RAM. It's going to load, it's going to, it's going to load any detection model or whatever the model using that, because that's only less than 3 GB. Some of them are like in MBs, 250 MB, 300 MB detection models. And then element extraction, we're taking blocks, which we already have. I showed you some chunks. And then we do tables, and we have formulas, and we have pictures. These are the four main items we have, which is in element extraction for the entire page, because we need to accurately pull in visuals. That's very important, because we, according to the Notion page, you can see we work with a lot of 40% of scanned documents, and they have a lot of technical jargons. They have a lot of equations. They have a lot of tables and etc. So that's it. That's the accurate extraction we think. We're not doing like chunking, like giving a document in chunk for 512 and with overlap. That's not what we're doing. And this is a custom pipeline that is purely open source, run by open source models. Okay. And then we have a VLM processor. Now extracting tables formulas, pictures are all parallel stuff, and nothing is dependent on anything. You don't need the other context to work on this. So we can run everything parallelly now because we have a compute capacity limit. What we're trying to do is that we are only running 3 VLM workers for one. For example, then what happens is that when you get into tables, let's say you have 50 tables, you only have a worker that processes table 1, table 2, table 1, table 2, and formula 1. That's how the mode will get changed up. So in a given moment, you'll only fire if you have tables mode, you'll probably have tables running and then formulas, but the max per document, the maximum will actually be 3 workers, meaning there's only an the maximum for each document could only be a table or a combination of formula and tables and visuals and etc. But still everything will be limited to 3. And then we are running VLLM through FP8. Now FP8 is very good because H100 is made for it for floating point numbers, and we are basically just pulling out that 9 to 10% accuracy levels, or maybe the precision levels, what you won't get on an A100 running int 8 or consensus version of 4. We're trying to pull that level of precision as well. Now of course, depending on the GPU, the customers you work with, this could actually differ, but yeah, because I have an H100, we definitely want to go with FP8 here. And we have table extraction, we have formula, and we have picture descriptions. And for table, we generate a markdown, like you detect a table and get an accurate markdown. In worst tables, we just generate descriptions and pass the model. That's very worst case, like 10% of the scenario. Formulas, we get the latex extraction. We are also the nodes, so we can do searching, semantic search. We have pictures with descriptions. So descriptions is only used to match the images. Once you find the image, if it makes sense, the model can actually view the image, right? The description do not they go hand in hand, where you just do a base search on text, and if it's relevant, only you see the image. Chunks assembly, text box, and we do all of them parallelly, so we do not know in terms of like a PDF reading format what is, even in Qdrant you probably have to restructure the final chunks, so then it's actually in an order of an actual document, like you have a formula and then a table and then an image. You can't put them in very different ways, and there's like very order, so we are accurately mapping up the order and getting the final chunks. Each chunk is about 1000 tokens. Yeah. And embedding generation, we're using quantized 8-bit. For this, of course, we don't, because it's an embedding model, we don't need to care much about that. So batch size 128 chunks, output is 124 dimension, and semantic search for each chunk. Yeah, it's just some random shit, I don't know why it uploaded it. So vector storage, easy. You're processing everything on Qdrant. We'll manage to load, we'll work on the speed indexing and later once we get the Qdrant up. Wheeling processing pipeline, you have the, so this is just to give you an indication on like how we do the tables and etc. But you should definitely go and watch the past streams. Essentially what we're trying to do in a table, in a page, we take a screenshot of the table and then we send it to the VLM. We also have access to the locations of the table. So in case the VLM, the model needs to see this table visually, it can really, like a human, open up a PDF and then go above where the location, search above where the literal location of the table is, and then read below, read above, whatever it wants to. We have VLM API call, Open API compatible, doesn't matter. And this is, of course, I've explained. Concurrency breakdown, we have 24 documents. Each document is its own thread. So own thread would actually have maximum of 3 VLM workers. So we'll have 72 current VLM requests. That's the maximum. We're pushing it to the limits, to be honest. And we have, we'll start with RAM. Basic is 314. We have the PDF buffers, to load the images, embedding batches, and etc. CPU equals 40, and that's why we also limited for 24 documents in a thread, and Python workers 24. So Ollama will use about 8 threads, and you have Qwen 33 gigs. The model itself is low. If you were to see, we could even run this on a 5090. But we won't be able to run 24 documents with 3 VLM workers for each in a parallel way. That's why we need that extra 55 GB of VRAM to support that 72 concurrent requests. So in case, and you also see, and this is also one good thing, is that 72 concurrent requests for a maximum token size of 10,000. Not 50,000, not 100,000. In real world scenario, when you do inference, when a user or a researcher scientist is actually using the platform, 10,000 is nothing. You would actually need to allocate for 100,000. At a minimum, you need 100,000 tokens to do something, in terms of like a research. So it'll actually go 100x down, where you in a given scenario, you'll only be able to in a single H100, you only be able to support 5 to 700K, real-time requests if you were to deploy this system, in a production environment. Where with one H100, you can actually do, if there's 10 people using it at the same time, there's only, yeah, that's what I'm saying. Maximum with all of the whatever the dynamic caching or whatever you want to do with VLM, you can do. I mean, all of those stuff is different. You can do dynamic cacheing, etc. But assuming that you have you have company with a lot of people, you have one H1, maximum level of people who can use it at a given time with 100K context length would actually be, if you see 72, probably like 7.2, probably around 7 people could only see that, and the other people would need to wait in a queue until one like wait in a queue, so then the initial 7 requests is processed, and then they could run it on forward, stuff like that. And you can also, like, of course, if the company is very limited on compute capacity, you can do a queue where one question is answered and then this loads up and then this goes in a queue, this goes in a queue, and etc. But yeah, I'm just getting it to the point, just giving you some point there. End-to-end flow, Dockling, passes and stuff, yeah, we know this. And yeah, cool. So that's what I wanted to go over, so it sort of makes sense visually to see what is really happening, because for the people who are joining in the middle, you have no clue what we've done, and this is just a visual representation of what's done and what is actually left. Which, I mean, this is exactly what's going to happen in the GPU, right? So we'll save this up, and for now, I would just want to test with 3 documents and verify, and to just do a verification test if we all have the progress working, if Qdrant is working, if nothing is failing, and stuff like that. Yeah. Yeah, cool. So let's create a quick test, make directory of test docs, and copy that. Just copy around 3 documents to that random 3 documents. Yeah, put them on commands.txt. Okay, so we have 3 files. Let's actually see it ourselves before even okay, I'm not able to see the file. Where is actually say mount data? Okay, the thing is, all right, now I want to copy these files. I want to download these files to my local system quickly just to see what are those. It is already copying, it's already in the process of copying. Just double click. Okay, it's downloading. Let's wait a bit. And see the size of this PDF. There. And this is a single PDF. Huge, huge PDF. And you can see the level of tables we have, the level of diagrams we have. Damn, this is very good. I would say random test documents. But the thing is, we've actually solved this stuff. Like every bit of pieces here is solved, and this is from 1959. Even better, we've dealt document as old as 1954, as old as 1950. Where this looks to be very clean compared to the other documents we've dealt we've passed as well. And yeah, we do a lot of, and this is just the pipeline UI. I mean, the visual you saw is very simple, to be honest. We do a lot of extraction, metadata extraction, removing noise, classification, detection. All of this black color noise is removed. We do a lot of bounding boxes. We do a lot of sketch and painting in the documents. We'll do a lot of um, uh, detections. For example, if I were to show you, I'm not sure if it's here, but if I were to show you boundaries annotated, I'll show you one of the images here. So you can see this is how we work with a lot of annotated images. For example, this is how we do the extraction itself. So it's not like you pass in a model and it takes formulas magically. That's not the case. It's quite complex, and all of this will be open. I guess it'll be open source. I'll probably put it there, but at least I will have it as a product where you can, digest, put in your documents and digest them. And if you want like an open source version, you can get a license, or maybe just hit me up and I can give you access to something. Yeah, but let's see. So we have 3 documents persist, and some of them is actually, oops. Yeah, this is a PDF. I don't want to work on this such a noisy mess, to be honest. Yeah, I'll be like, I only wanna okay, so I wanna randomly pull another 3. So I'll be like, I wanna randomly pull another uh I would say another 10. Actually, I wanna copy 10 unique docs to our test NASA docs in the VM, and then I also want to download it locally. The thing is, this is such a mess. It's yeah. The thing is, I won't be able to validate this properly. I want to spend some time on it, but I want to have documents like this, which looks like a very technical paper. And of course, our system easily supports this because everything is an image here, and we have some text and everything is image. It's not an issue at all, and it's very clear as well. So it's not a big deal. I just want to, what do you call work for the worst case. Yeah, hoping that the best case will be automatically solved. Fine. So we'll just remove this and then we'll run it back. And put 10 documents. Should have 10 docs. You can see the list of 10 documents. Good. We'll download this in the first place because I want to clear a few things here. So I want to download it and verify this. Okay, so we have the documents. This looks good. This also looks good, and also this is very different for documents. You can see it just because you have a different, like first initial page, very different for documents. You can see it very different. This is good. These are good. I just want to remove all of this crap. So what I want to do is that I want to remove some documents from this. And I'll be like, okay, so I want to remove all of this. Yeah. No, I want to remove the stuff from the images. I've sent you an image. I just want to remove all of those three. Just put the all-in-one in the command file. So any terminal command you work with, you should put it on the commands.txx. No, actually, no. Just give me, just put that up, the all-in-one in the commands.txx. And we'll verify this. And we have this document. We'll locally, I will locally have it, not an issue. Cool, we're ready for ingestion. I think we're ready for ingestion, but I want to share this info with you because I can see this is 92% full. Which means already 88 GB allocated. Update the ingestion file because I want to see the monitoring separately in a terminal. So for now, just comment it or update it with the test docs. Yeah, I want to just test it with the test docs and then update and run for the 10K docs. Curious to know, there seems to be uh, nothing running on the model, but still we have 88 GB allocation. Could we which means that would the numbers still align? Will our numbers still align? Because we assume that before it was actually 33 GB of model load and we could do 24 docs. Can we still do it? I think there's a bit of lag here. Let's see. 7 documents is okay, but 24 because the memory is already 88 GB. I was assuming it should 30 GB. No, I know that. I know we made them. We made them at. Yeah, VRAM pre-allocation GPU memories are the best for 90% of the. Okay. Yeah, so I guess we loaded. Okay, that's what. Yeah, because I totally forgot about the number, and we did memory allocation 0.9, so that's why we have nearly 92% of allocation. Because we already pre-allocated. Yeah, yeah. I thought I definitely didn't see the command. See command. Okay. Yeah, and you can just GPU memory is 0.90, which is 90%, and max model length of 10K, and that's why we have 92 GB allocation. So we'll run this. I guess we're in good shape. Cool. Actually, I want to first test it for 3 documents because I don't want to wait until it completes the 7. I just want to test it for 3. So we'll run this ingestion for test folder and we'll actually run it with 3. Says one. Oops. No, it's fine. I could have any amount of PDF in the test, but I only want to run 3. Right. Okay, we have an error here. Oops. Let's verify if everything is running. Hey, we have Qdrant, everything is running. Okay, port difference, go. We resync it. Oh, actually, this is a different file. We didn't sync source. My bad. Sync monitor. All right, it's the process has started. I can see the process is working. The compute seems to be updating, but of course the memory seems to be updating as well, but I don't see any changes in the progress or documents or the other vectors or whatever. Cool, but we can see the memory capacity is almost 98%. And that's what I don't know whether we need to allocate GPU 0.90%. Maybe we shouldn't. We just let the model use as much as memory we have on the VRAM. And that's also minimum. It wouldn't affect it. If you were to look at code and technically understand it, wouldn't affect it. Start the monitor. Let's restart the monitor. Okay, so we don't have yet any docs processed, but you can see the bump in memory and the bump in compute. And I guess this is loading every second. So yeah. Oh, we're still using open router. Okay, we've hit this issue. CUDA out of memory. Damn. Yeah, assume this will be an issue. I'm getting a ton of errors. How do I kill? How do I kill this? Not the monitor, but how do I kill the process documentation process? I need to force kill it. So now, All right, now we have actually a ton of issues. It seems like we still have something somewhere hardcoded using open router. Just to save context, here's the summary of the errors. You can see we have document extraction issues. More than that, that's only like a VLLM sort of thing. Not an, it's only because of the CUDA processing. But we actually hit an issue with this computing. See now, Dockling is using rapid OCR, and we need to. So that's our thing. Like, yeah, this is expected. I mean, our math just have to work nearly as planned, not as accurately. And now we need to give some now we need to calculate how much RAM VRAM it needs, and then sort of change. Um, yeah, basically change the what do you call it? Change the numbers a bit, but it's okay. What options are you even checking for? The GPU man, because episodes try to use GPU, but VLM occupies from Dockling. No, but just let me know how much of RAM would it take. I mean, that's one of the reasons why we even use a GPU, right? Let the OCR be running on a GPU. That's totally okay. Our numbers might change a little bit, but we're not trying to accurately get it. So that's such a stupid decision here. Now the thing is, do we even need to allocate memory utilization? Because no one we're not using the GP for any inference. You should know that we are only processing document processing. That's it. In case there could be a little bit of there could be some other services that can actually use the GPU a little bit. You can still initialize with 0.85 if you want to. If it's safe, we can still do 0.80. But yeah, I'm just saying, what is the pros of, I just want to understand what are the advantages of pre-allocating memory, and then what are the advantages of dynamically just leaving it. I'm sure there are pros and cons for each, but just let me know. Yeah, I'm just trying to understand, like, for this particular use case, I know there's like OCR wrapping on rapid OCRs, and there could be another services trying to use, maybe in the layout detection model itself could run on a GPU, because we have access to GPU. That's why we're using a GPU in the first place, and we could save a few seconds from here and there. But I just want to know, and yeah, we can still, the thing is, like, we can dynamically keep it. For example, let's see the trade-off: pre-allocation with LLMs. Deterministic performance, no memory fragmentation, allocation delays during inference, can handle burst concurrent requests, blocks other process from using GPU when idle. Other process sources can use GPU, could use Zoom if multiple VRAM. For use case best parsing, not a web server, you don't receive pre-allocation. The pipeline. Okay, so we'll keep the 0.80 and keep the rest 20, not 20, I think. Yeah, probably 17 or 18 for any other services, which also means that we can't do 24 right now. We can only do 18 or such in a given moment, but it's okay. No. So it adds another 1 hour of processing. That's it. Finally, it's just an hour of extra processing. Anyway, I'm just going to run it overnight, even if it takes 13, not 13 hours. Even if I run it now and just wake up tomorrow, you still have about 18 hours. So yeah, yeah, we should be good. Okay, we'll do. Okay, so go back, kill Docker. Oops, no such thing called real. I can start Docker manually. So so I can see the logs. Just and of course I can connect and see, but I just wanna start it manually. I think I revoked some code. We don't have. No. This. Okay. Seems like we're running that. Oops. Oh no. I actually want to run Docker manually. Add this command to a text file or a command.txt. Please include the commands over in a file because I'm not able to copy the white spaces. The Docker doesn't start for some reason. Clear on that. So let it load. Open up the monitor. All right, so this is running and we have 82% memory consumption. I think we can modify this. Okay, so this is running. Let's process the final documents. Okay. So consumption is going to 88%. Compute is for 2. Okay. We're still good. We're still good. I hope I don't. Hopefully nothing crashes. It's going to 98%. 89%, sorry. I'm wondering if you're sequentially processing it. Okay, can it be used because it's not installed? Okay, I think I can see a couple of issues here. I can see there's a couple of issues. Do not jump into code yet, but let's just, yeah, give me a summary of what's going on. What are the issues? So we can see it's still trying to call the API. That's the thing. Okay, so image calls are working. I guess first of all we need to get the test API call working. Actually resync them, to be honest. I want you to write the test quickly that calls the models and this is base like uh, just checks the inference is working for VLM. Just a sample code that I should run to be able to verify that the models are responding and they are working. Because right now the models are loaded, but I don't know whether it's responding or etc. So I want to be able to just in verify command just fire off a like sample query, sending an image on just not the image, just a text, just to see if that the LLM is responding and working. I actually want this test to be part of verify setup as well. Like just have that there so I can just run one single command and see everything is working. Input PDFs working, data distribution working, response got source on 4. I think it looks good. I think it's working. Cool. Now we'll start the ingestion. The thing is like this now, there's a good chance that in case our math was wrong or some issue, some in case we've missed something, right? I'm not sure what we've missed, but we probably missed something. Where in the middle, if the VLLM were to crash, I don't want to get into any of those scenarios. So what I want to do is that accumulate all the logs and everything related to the compute, to the GB, all the logs for each docs at each stage, and sort of send it, sort of analyze everything, and then come up to a conclusion whether what limit would be, would 20 be a safe number, would 22 be a safe number, what would be the sweetest and the safest spot to run it and just keep it up for night and hopefully it doesn't fail. Yeah, that's what I want to do. Okay, so waiting. The models are working. You can see the logs. So far, I don't think there is any issues, but I can see elapsed time is actually, okay, I can see all of this as well. 10 tables extracted, good. So stuff is working out. But I can get now when the monitor is, so we just ran it like a couple of minutes ago, but the monitor shows 14, but still a document should have been done by now. Maybe there's a lot of tables and etc. But let's see, yeah. I think it's with the token limit. But not even just see 0 documents processed. I know we'll hit this bump, but we'll solve it. I know there's some issues. Solution 1000 models maximum. Yeah, we'll make it. Yes. Close up. Close to Docker as well. We'll make it 32,000 and run it. Thirty thousand, run it. And I also want to check. I guess one. I guess one of the thing is we can actually see current in case it's actually running. So it was on port 663. So what I would do is that I would go to 13 point 13 point slash port 633 maybe. Now I'll be like, actually I can see one document is being processed. I just want to quickly check if it's processed or not. I want to check current whether one document, the chunks of the document exist or not. In fact, you know what? We'll actually check it later. When yeah, probably it will have the test chunks. I want to clear. I want to clear quadrant and then start the test command, and it should be an option, not always. In case if I had to clear the quadrant and run the ingestion, I would wanna add it as a command. You can see no SF28 fine. It's basically like metadata. Oops. Oh, oh. Give me a summary of the error with all the details of what's going on. Just give me the error. Do not give me any fix info. What is the what would be the time difference if you were to go from GPU to CPU? Because I've been running the Dockling models on my CPU and it's not that big of a difference, but just small because those models are very small, right? It's not like very big, huge models. So I'm just curious to know what's the time difference. If not, we can force it to use CPU. Hmm. Right. So we are forcing it to use CPU for OCR and table extraction, but the underlying VLM would be much faster. Uh, Not much faster, but I wouldn't say much faster, but it'll be stable. It'll be stable. So we'll restart it and run it back. We have this. Oh, okay. I know what the issue was actually. We forgot to update that. Yeah, this is an old command. I totally forgot to update it. You know what? We'll actually kill this process. Keep it at 32,000 token. 32, but keep it at 80% utilization. We'll try this and see. We'll try this and see. But if it was to allocate for 30,000, then let's see the monitor. It should be, yeah, it should take about 80, 85, 82% of the memory. taken 82%. It's taken 82%, so let's go ahead and run it. Same thing, test talks. They have output directory. Okay, the thing is, all right, now I actually want to calculate at the end, calculate the time it took. Are we saving the time it took to process each document, or at least the entire batch of document? For example, in this case 3, are we because I wanna like realistically see, how long will it take, because each document might have, like, let's say 100 tables, then the processing time might be a bit more, right? Because we're using CPU for table extraction and etc. It's totally okay. We don't need to stick to the 8-hour time frame. It was just a goal, but just curious to understand, are we saving it anywhere? I want to see for the first 3 documents how long did it really take. I think, guys, it takes about 10 minutes for 3. Okay, that's good. We will process this. I want to see how many documents are processed at the same time. Okay. Phase 1 ingesting 666, 11, 885. Okay. Cool. 3 is going on. So let it run. I think my gut feeling is that it's gonna take way more time, and I'm okay with that. If 3 documents takes 10 minutes, then how much would 10,000 documents take? How many hours a day? Oops. Then how many days is it? It's actually, damn, 20 days. 23 days. Damn. It's too much. I can't afford it. Because that's what just now I realized, not just now, but then I realized is, but some document you can't expect a document to complete in a minute just because it depends. A document could be as long as 10 documents, right? Like, for example, one of the documents that we did see was actually 100 MB, 115 MB. So then, yeah, there's a bit of intricate parts for stuff like that, to be honest. Yeah. But yeah, let's see. One document is done, I think. No, not yet. Shh. computed at 100%. I can see that the rapid. I can see some logs in between saying rapid OCR return empty results. Would it affect our system in any way? Yeah, but it's fine because we reduced it to 80%, right? Okay, so it's generating embeddings. Put 83 chunks, 40 pictures, 10 tables, 0 forms. Could you please check, do a quick check on wherever we're using open router API in the production code? Just do like a quick sanity check before I start and racing the code. We're going through the final doc. Seems like I've copied the entire code to the SSH machine. I only needed this and whatever is related to a deployment. I need to revoke that. No, that's what I'm saying. But you gave me some command and I didn't I didn't take a look at it properly and I probably processed everything to the VLM. But that's fine. I think that's fine. It's not an issue, not an harm. Yeah, that's the only thing that I want, but I have processed everything. So the entire folder we have right now locally is in my VM. Mm. Yeah, I think we'll have to spend a few hours in this for sure. Hit a lot of issues for sure. Because I did something and I just took off the entire. I actually should have put all of this, just moved it to source. I just deleted it by, yeah, just a stupid move. And this time, I'm gonna, save time by running this. Actually, increase this to 32,000. I guess we can actually put it to 20, but it's okay for the sake of doing it. We'll just do it. Let's load this up. Okay, I think you gave this command, and I don't want you to forget about this. That we have something like this. You wanna only copy the relevant steps. So, do you wanna save this in your memory? All right, so everything is okay. Seems okay. We'll actually, what I would say is that now I want to keep it simple. Update whatever the code you want. I want to only process one document at a given, just one document for now, and see how much time it takes for one document. Because I see I can feel there's some issue with parallelization. Nothing seems to run parallel. But yeah, anyway, we don't know yet. I want to run one first and see. Just one. I want to see the progress and everything for one properly. Oops, sorry, I was actually on mute. Then copy this. I no, we're gonna verify if that doesn't. I wanna verify that there's only one document before I proceed. There's only one. Cool. So you can see for the one document, phase one actually took 172 seconds because we are running on, I guess, CPU. I hope so. I think, yeah, because we're running on CPU. We're adding another 60 seconds addition. And phase one completed at, yeah, easily. I think about 3 minutes per document. Then of course it's not still, it's still done. It's still going. This is very slow. I would say this is not this is not the expectation at all, but it's quite slow. Yeah, very nice. But I have to somehow fix this and to find what the root cause is. I need to check how much it took, but it took a lot of time, I think. So yeah, I need to check it. Yeah, VLM is fast. Then it's 50 images, so we're getting a response for each second. We're getting about, yeah, 1.4 seconds for each image. Symbols extraction is okay. This is taking 48% of the time. Yeah, but I also now I've made the GPU. So I wanna I wanna run the Dockling OCR one more time through not through CPU but through GPU. I want to try that and I want to see what the difference is. Yeah, because because if you were to eliminate that, then it'll actually be uh half by really half a chance. Yeah, let's see. So I'm gonna get rid of this progress, and of course I can see it wouldn't give you an accurate assumption because you got to just check the compute and memory for this. Don't focus on a lot on this. Now we will actually go ahead, remove the single log, oh, and then run this. Because it is one unclear. We'll see this in the GPU. Like 172 seconds. There is actually no need for the guess. So what we can do is that the so what we're doing 172 so 172 seconds is for paragraph detection and etc, right? That's what Dockling is doing. What we can do is that, fall back to chunks. We'll do the general overlapping chunks, just do OCR. The thing is, I don't know how accurate will it be, because it's actually doing OCR for all docs, or I'm not sure if it's doing OCR for all the docs. I'm curious to know, is Dockling doing OCR for all the docs? Because it doesn't need to do OCR for all the docs. Maybe that's why, maybe only for old documents and maybe not for all the old documents. For example, I can. This seems to be a bit fast. Let's see this was maybe okay. So also curious to know, if you want you can check the docs, but I want to know if, yeah, yeah, the thing is we're mainly working with a lot of old documents. That's the thing. I can leave it for 42 hours. You can definitely do that, and I can come back once the entire process is done. Leave it to 42 hours, because that, if not, I can actually, if I had like access to 2 or 3 H100s, I would probably invest in them and probably do it. But in this case, yeah, it's actually a nightmare. It's actually a nightmare. And so you see, you can see the images. They're quite fast. These are figures extracted. Yeah, these are quite fast. And of course, for symbol detection, you would know the trick. What we do is that we do, first of all, do a bit of like rag on that and try to find the symbols, and then try to reason over them and try to find the right page and get a screenshot of it, do a bunch of things. And that's why maybe we even see this number of for symbols, and that is very important. Metadata symbols is like damn important, and that's why we hit this 60-second mark for it. And tables extraction itself is very good, because there could be a lot of tables and it's doing it in 59 seconds is good. 69 seconds for 50 images, good. This is what, if we can slow this down, we can cut it by half. And even if we were to run it, in worst case scenario, we'll only run it for 24 hours. Like if I were to run it tomorrow same time, we can come back and see what's going on. And in the meantime, we can expose it through API and start ingesting, just start using the models and stuff. um yeah, I guess running it on a GP is much more better. What do you think? Of course, like, what do you think? Of course, instead of 177 seconds, it's actually right now 53 seconds. And then we can see 206-second drop, which is like 4 minutes. Yeah, less than 4 minutes, something like that. Huge improvement. So 1.7x fast. Not sure if CPU can handle it. Actually, give it the configuration. Actually, this is the VM system info. I'm not sure if it can handle it. I know it's a 90. Yeah, there's a look. Okay, guys. I think we can figure this out. It in worst case, we'll end up running it for 25 hours. That's it. I'm okay with it. Of course, because we are compute deprived. To be honest, even though we have one H100, we are definitely compute deprived. What else? All right, I'm gonna go for a quick lunch break and come back in 20 minutes or so, and then we can continue from there. Yeah. If you have any questions, definitely drop it in. Happy to answer them. Yeah, I'm gonna quickly go for a break and come back in a 20 minutes. Yeah, but then yeah, at worst case scenario, we're gonna run it for running for how much? We probably want to run it for like 25 hours. If I actually had like a B200, and guys, like the things we can do with it based on what it goes, because 32, you can run it estimated time 19 hours. The bottle thing is not GP1 VLM for processing. Exactly. And also one more thing. No, I don't think we can speed up any of such. If we were to take off the symbols, then but symbols context is very needed. So if I can run it now, right? I can run it now and at the same time I could come back. So let's say that's fine. That's a good number. All right, guys. All right, all right. So I'm gonna go for lunch, quickly come back, and then we can take it from there. All right, see you in a bit. Alrighty. Yeah, so where did we leave it? Cool. I want to quickly check Qdrant if all the data is saved in Qdrant. Cool. At what port is Qdrant running? I actually would like to check Qdrant. I know. I mean, of course, in our update, we did see the chunk did exist, but just as a verification, I do all of this dumb verification, but saves you an hour. Like looks very dumb, but saves you hours of time. Like in case something goes wrong, crashes. You would never know. You would never know stuff like this because these are like, you have a ballpark and you sort of operate sort of thing. Please include this in a file, just a random file. I'll copy it from there. Yeah, so we have the chunks. And these are normal, these are part of the OCR. So yeah, I think we're in a good spot. We just have to, we just have to run it. And I want to have some safety checks as well. For example, let's say in between a couple of documents fail, maybe in 9,000, 5,000, 6,000, whatever. Some document fails, right? I don't want to restart it. I want to continue it and stuff because I want to continue from the from the failed one. So Qdrant is working. Here's what we see: test talks 350 chunks, the multi-doc test. Now I need before I move forward, we have to be also quite practical about the safety here. In case in the middle we run out of GPU or something like that, I don't want to come again and process everything again. So I need to keep in track of what documents, let's say 10,000, they be processing all the 10K, what number I need to be able to know which documents are processed and which are remaining, and just process the remaining only. Not process the document is already processed, right? Second thing is that I also want to send me an automatic, because I won't be looking at the system every day, so I want you to send any warnings or failures, or maybe for every for every 500 documents, send me an email. I need both of them for safety. And don't jump into code yet. Just see what are the changes that are required for this to happen. Yeah, because I need to have safety in case, there's a good chance there's a 50% chance, I would say, guys. This is very high, but still, there's a 50% chance this could break in between, and you would know why. You would never know why. So then I need to know the reason why it broke. I also, yeah, more than the reason, it's fine. I could rerun it, but I want to rerun it not from first, in case I stop. If I don't have the track, if I don't monitor the tracking of it, then I'll be in danger. Then another 2 3 days gonna be, quite wasted there. So checkpoint current state has no state tracking, crashes at 5,000. You restart from zero. Changes needed. Mm. I will do SMTP just to my Gmail. It's enough. Want to proceed with implementing those? If so, the email service you prefer. Let's go with SMTP. So if I were to run it today, by tomorrow this time we should have it. All right, I just added my password. What should we do? Should I add it back to you? Right. Oops. Could we quickly test this? We'll install it here as well. Install it here. Okay, let's check our Gmail. Meridian test email from Meridian ingestion engine. If you have received this email, you're working correctly. Okay, good. It's working. Nice. All right. I also want to know now. I think we already saved this, but would I be able to know for each document how many tables, how many formulas, how many chunks were passed, and because in case the document takes double or triple the amount of time general document, right? We need to know whether there was more tables or whether there was more formulas or whether it was symbols or etc. But I think we do have that information, right? From the past test, I think I can recall it. But check and let me know. Because we need to know in case something takes time, whether it's actually because of more tables per person. Like for a single PDF, we estimate is like 4 minutes, 3 to 4 minutes, right? But in case there was 100 tables, then yeah, then it's basically equivalent to, I don't know, 10 to 20 PDFs or something like that. So it'll take that amount of time. Yeah, sometimes yeah, we don't want to a document might even be, for example, like there are like 700-page documents as well. So in that case, it might even be, I would say, easily be easily take more than 20 to 30 minutes per document. That's why in a lot of companies they actually have a lot of what do you call, a lot of they have a couple of GPUs, and we are using 10,000 docs for like only one H100. But they have, a lot of companies do have, not a lot, but the companies that I work with, they can afford a very good amount of GPUs. So we have multiple GPUs to be able to take on if needed. The documents are look significantly longer. Like it's just a list, so we'll add it. No, thing is like this now, because we're gonna run it parallelly. If we were to, if we were to run, yeah, I want to run one parallel batch. So for example, right now our goal is to get it to per document to be 3 to 4 minutes, right? Maybe say 5 minutes, but then 5 minute, like all the 24 documents or 32 documents should be inside the 5 minute frame. If that's not the case, if it's 10 minutes, if it's 12 minutes, then there is some issue. Some either we are not running anything parallelly, I mean we are running anything everything most of the stuff parallel, or something is actually waiting in a queue, or something is wrong. In our code something would be wrong, so we need to visually test it. Even though the code is all right, you process stuff, but there's always yeah, you can always have some glitch, not in code but in like in terms of processes I'm saying. Good. Now I would now assuming like with all of our changes, a document might take 5 minutes, right, max. Then how many documents are we planning to run um, at the given time? Because you gave me some information on number on 19 hours or something like that. I'm asking based on that 32 workers and etc. So curious to know. Okay, we'll start with 24. So how so at worst case, how long will it take to process all the 10K? Yeah, so the thing is, even though it's yeah, uh, maybe tomorrow, we've only done with 5,000 docs. It's totally fine. We can start with 5,000, and we can build a rack system and connect it to the quadrant and etc. and just go about it. So I don't see that as a problem, but I'm seeing if we can reduce the number of days with 24 workers, it'll take 26 hours, probably a day. If we had three GPUs, if we had like five GPUs, it's like a 4 hour job. If you start Friday evening, okay. Okay, but I want to check for the first 24. So if let's assume, with all of our past tests, per document takes about 3.5 minutes. How much would it take for 24 documents? I guess we have 24 workers, so 24 workers would still take 24 documents will still take how much? 24 documents will still take under 5 minutes, right? Which means now I'm gonna run it and test it, and I'm sure this will take more than 5 minutes. Also, I guess what I want to do is that, let's say, whenever I process, right, whenever I type in the run with 24 workers or whatever, I want the monitor to have this, state as well. For example, if I were to process this, the monitor command is showing something else. What I want to do is that it should be simple. I don't want to meddle with a lot of code. Whenever I run this, I click on monitor, I run the monitor file, and it should basically, and this is a current session, right? This is what we are working on. So then it should have that specific info, like if it's 24 documents and then 24 workers or whatever. You understand? Yeah. All right. So use 5 minute window if rate available. Use window rate. Okay. All right. When you run an ingestion, it writes a session.json to the output directory with input directory, output directory, collection name, number of workers, start time. When you run the monitor, it auto detects the sessions.json and gives you an info. All right. Also, I want you to, so whenever you give me, whenever you give me commands that are more than 2 lines, for example, if you were to give me, for example, the first one, right, first code or the terminal thing that I can run, I want you to give me on a, there's a file called command.txt. I want you to add it to that, and I'll probably pull it from there, because I'm not, if whenever because when I copy, I probably am copying the white spaces along with the white spaces. So I want you to save this in the memory. So if it's a single line, no, no problem. You just can give it to me through your chat itself. If not, I want you to update the commands or txt or whatever, so I can copy with all of the, without messing around with the white spaces. Yeah, I know it's some issues with configuring Claude or something. I can use the Vim version or something. I don't know. I just figure it out later. Okay, so let's see. It is like, oh, so I think I was actually planning to, share the project, the progress on Reddit on this Friday or something, but yeah. So we have, then we'll aim for next, probably coming Wednesday or Friday, I think. Yeah, not this. Because this itself would take 3 days. It's okay, because we have only limited compute. With VLLM at 70% and 20 workers, scenario, this case 1.7 days, worst case, actually, yeah, at worst case, 2.1 days. Yeah, 2 days is okay. 2 days without crash. Yeah, that's what we want. Let's try 20 workers setup. Okay. Okay, before that, now I'm not much experience. Assume that I'm not much experience in infra, or I'm not much experience in a lot of the GPUs. I'm not experienced in any of things, which is in reality, I don't even know a lot of those things here. What's really in terms of what's happening under the hood at low level, right? So I want to know, is there anything that you would like to tell me, or I should be aware of, that I can that we probably missed, which we could have incorporated with the current setup we have, which should probably reduce, make it more efficient, or process in a much faster way or whatever. So this is something that I want to do, like a meta thinking, where just assume that that, because you're going through my words and going through what I'm guiding you on, but if you think there could be some other better way, much faster, much efficient way, just feel free to let me know now. So guys, what I do is that, now the thing is, if you were to tell Claude do this, do, they'll probably do it, but you could easily miss so many information, or you could easily miss so many ways of doing the same thing. Probably there's a better way of doing it and you didn't even think about it. And even though how smart you are, will definitely miss something. So I'm sure I'm just gonna send this message, because I'm sure I'm probably missing something, I forgot something, or um which Claude could bring up. So then I have to put myself in a shoe that I have no clue about this. You have to literally, so then your past assumptions will be invalidated, and Claude could bring in something, I don't know, something unique, or not unique, but some good workaround which you were not aware of, because we didn't even start from that s- from that thinking or that approach in the first place. So probably there's some way of some other ways of doing it, just some creative workarounds as well. So yeah, we'll see. PDF Dockling, yeah, this is all okay. GPU memory right now 70%, 20, okay. Improve the 32 model might be an overkill. You're using VL32 for converting tables, markdowns, etc. At 7B or 14B would likely work as well as this task, and would use 4x less GPU memory process. I mean, of course, it's reducing the model, doesn't matter. VLM is being called many times per document. If a document has 10 tables, 10 VLM will call, 5 tables, 5 VLM, gate pages, 23 API calls with network overhead each time. Could batch these into few calls, but would require code changes. Yeah, actually, we can batch requests. I didn't even think about it. Yeah, yeah, that's good one. Formalization runs twice. Looking at the code, runs VLM to detect formulas, runs VLM to extract them. That's fine. That's not a big issue. There might be redundancy here. Documents without tables or formulas will go through the full pipeline. Some PDFs are text only. We could detect this early and skip VLM entirely for this. No, we can't do it. We can never. How could you even do it? Embeddings could be faster. Ollama 4 is running locally. Dedicated embedded services GPU embedding could be faster. Yeah, that's true. We can try a small model. Then it'll actually take 1 day, but I don't know. Like, what if the accuracy is very low? I can't afford to lose accuracy here, because accuracy is very, very, like, super important here. Because, for example, even in JSON output, Qwen fails to, even if you've used Qwen, it fails to output proper JSON. So inside the code, even if you force JSON, right? So inside the code, we also have retries. And 32 billion in a given 100 queries, easily 5 to 10, you'll have incorrect JSON. Then we do another retry for those 20. If we do 7 billion version, then we'll do retry for, I guess, easily 50%. That's not good. It's just a couple of days difference, right? A day or two. Yeah, this of course is right. Yeah, you're true on the 7B version. We will come to that, but I'm actually interested in this. Could we batch requests? Like, could we send a batch of requests to VLM? Um, and also, I'm thinking we mentioned workers, right? For example, if there's 100 tables, will 100 calls be made at the same time? My second question is, if you were to batch request, how fast could it make? I mean, I'm pretty sure you can do batch requests in VLLM. So I'm curious to know how much time would it save? Yeah, let's try. No, first of all, I want to try. Yeah, first I want to do the 70% allocation and see if that works. And if it doesn't, then we'll actually jump to the 7 billion version. Okay. Okay. Let's start this, but at this 70. Also, curious to know, should we keep the max model length at 32,000? Would it affect the memory allocation? I hope no, right? Because I would say maximum tokens would only be, maximum 15,000 per call, per API call, maybe. So we'll do 16,000. I'll make this 80 and give it a shot. Just try it one more time. Let's see. Now the past, the past command basically, I would say. The thing is, I can't just keep on talking, and I'm just dead if I just keep on talking. So just type that. To check and the checkpoint system handles, you have two options. Just run the same command, we skipped all of the process talks. Okay, so we'll run this. So now we have 20 workers. You can see 79% of memory usage. And also, I think this is one of the reasons why people also don't have a lot of content like this outside, is because it's very hard to afford. Like personally, if you're making a tutorial, like if you were to, like, just leaving aside all the technical aspects of it, if you were to rent a GPU and run pod, it'll actually cost you $700 a day. If you were to keep it running for 3 days, it's $1,500. Like just for showing you the entire process of using the GPU and etc. And so I've been fortunate enough, I have some credits around 40K something in Azure. So this cost me, with all the discounts, 5,000 a month. But after 3 or 4 days, I'll actually get rid of it. Or maybe a week, I'll get rid of it. Just pay $1,000 in credits or something. Yeah, but if I had access to even more, then we could have looked at, you know, solving this in 5 6 hours. We had 3 or 4 H100s. So it's well under 95%. Either way, let's see. Now, I'm also not sure, maybe it's an assumption or if I'm getting it wrong, but I can see the initially for 20 workers, or let's say 20 docs, the context or the chunks are being processed. And then when it moves to a VLM, I can see there is no drop in GPU memory. I'm not sure if it's loaded and if it's not cleared out. Can you just check if, let's say, for 20 documents, the Dockling could efficiently handle this, right? We don't need to load the models again, save the models again. Like, let's say if it's like a 200 MB or a 500 MB model, you then need to save it. You don't want to make a copy of them and save it 50 times, right? There's context, that's different thing. But then once it's used and after BLM stuff is going on, once we've done with the chunking and all of those basic, whatever the process is, could we clear it out? I'm just asking, or maybe it doesn't make sense to clear it out, or there is no allocation being happening. I don't know. So I want you to check on this and let me know. But I have a gut feeling that the memory is not, the memory at least slightly should come down. When you go to VLM, you slightly should come down. I can't even see that slight come, slight drop in memory. And see, we are at 91%. And you can see VLM calls, no API call yet made. Not even a single API call is being made. It's now all of this stuff is actually Dockling stuff is happening. I can be wrong here, but check and let me know. This will also crash, guys. 100% will crash. I'll take a screenshot of this. Something saw failed. Stage process failed. Instruction do not match expected value for PDF operation. That's Dockling something. Okay, now we start hitting VLM. Now see the bump in memory. It won't even go down. This, I don't know, this error is. So I can see one document is, so just a process itself has taken 492 seconds, and that's 2857.pdf. Let's check the PDF. We should have it. No, I don't think we have it. That's, I think it's a huge PDF here. Check this. Understood. The process is still going on, but I'm just sharing a bit of info in the progress if you can make some conclusion of it. I'm just thinking, why do you even need OCR for this? I can literally select this text. You only need to use OCR where you can't select where you can't literally select this stuff. It's only image. I think it's using OCR for everything. Stupid. I think all of this PDF from NASA that we are working with is actually pretty good. And you can select the text. 2% left. I'm curious to know, most of the documents from the documents I'm working with are mostly I can literally on my Mac, I can literally on my Mac just select the text. And I think Dockling is complicating to use OCR for everything. I think we might not need it. We don't, first of all, it doesn't need to use OCR in the first place, because for stuff that needs OCR, like formulas, like images, like tables, we are already using VLLM to do it. So let that direction happen. Can we stop Dockling from using OCR? Because I think there is no reason to use OCR, because the thing is we are doing all of the processing, but I can be wrong. But let's see. Okay, at 99%, 1% more, and we'll have crash. That's it. Crash. Cool. Whew. Yeah, exactly. Actually, it's there. Hmm. Before making this change, I just wanted to know, I'm sure that there will be at least 1% in the 10,000 documents, at least 1% of them could be stuff that might need OCR. Is there any confidence levels or something that we can access? Based on the confidence, we can put a lowest threshold, and then only we initialize pipelines for what is it? OCR. Because I'm also curious to know how does it detect the document a document needs OCR or not? Can you just check this code thoroughly and get back to me? I want to understand the logic in case if you can write some wrappers around it. Or maybe try to make a proper decision. Yeah, we can do forced backend text true. So this is what we want. Prefer native text. In case something goes wrong, then use OCR. My recommendation, do OCR false since I think we'll try with forced backend text equals to true. So it prefers native text OCR only when fallback, and we'll see the results. And yeah, if that's good enough, we can continue with that because it will still give us a backup of OCR in case that one document might be in that 1,000 or 100 or maybe 500 documents. One in 500 might be OCR. Then you need to support that. And most of the stuff that I've seen, the pages are very quite clean, so I can trust that force backend true could work. So yes, we'll try that and we'll give it a shot and monitor and see how everything goes on. I think this will work out. Let's see. If not, we just fall back to text only. Sorry, yeah, text only basically. We'll just because all of this you can see I can scan it and stuff like this is what you need OCR for. Stuff you can't like numbers or formulas and etc. But we already use an VLM to do it. So it's just going contradicting with it's just double work. You're spending more memory for what? For nothing. I know you might have that little bit bunk, but yeah, you can avoid it. At this stage, you can it's you can still avoid it a little bit because we are doing all of this stuff in which is very limited amount of capacity. We can't get everything right, and this is also inefficient. Let's say 95% of the documents do not need OCR, and just the model just keeps on building up OCR because I think also one catch. See this right? This looks like you need OCR, but I can actually select the text. If I open with preview, I can actually select this text. Oh, I'm not sure if this is Mac related thing. These are not images, these are text. Like these are scanned PDFs. You can select the text. You know what I'll do? I'll copy to drive. I'll do PDF to text online. Drag and drop this. Start. I just want to see whether even a basic player like this could extract the text if then yes. And I can probably call it and we'll check it out. We'll run it and see it ourselves then. Oops. This is so bad. Yeah. Either way, we'll check it out. We know once we run it. And because we still have fallback, so in case if it doesn't work, we'll fall back. Alright, I need to sync it with I need to sync with the VM. Now we'll run with the same command actually and see it for us and see if this works. If this works or not. Clear this. Okay. I want to download the 24 docs that's part of the VM to my local Mac. So I can test if it's. And you can see the length of each PDF, very, very, very long, like super long, and very complex here. You can see the schematics in and all very old docs. 1965, 1952. Look, this is where we need OCR. So see this. So spending your extra compute on OCR is valid. And also all of this stuff, like the initial loading, right? This is not VLM. The Qwen is not causing an issue here. I mean, we're running this for I guess 3 minutes, 4 minutes now. It's trying to process all the text from OCR, and Qwen is not the issue here. So it's OCR. Actually, I would say actually it makes sense to use OCR because the documents, if I can see it right, they are quite scanned and they have a lot of issues. I can see that. So I would put OCR back. And yeah, also check the code. I think initially all the documents would complete the initial process from Dockling, and then only it will move to the next one, right? Which is a VLM. So what we can do is that first, before you we touch, because see, let's say one model completes OCR and it actually moves to VLM and it starts making all of the noise. What we can do is that at 24 docs, first of all, run all the 24 docs, get all the chunks, let the do OCR do all the processing. Let's not touch VLM then. And once all of the 24 initial stuff is done, then we fall back to VLM and use whatever because then we don't need any other, like we might need for detections and etc., but not for OCR. You can need it for OCR. I think it's already doing that. That's one of the reasons why we even have like good results from Dockling because we use OCR. If then, can you could there be in could you make changes to the monitor in a way that I can know the current list of documents that or the workers or whatever is going on is currently processing, and part of that, how much of that is currently in phase one, how much is in phase two, and give info on what is phase two, phase three, what is phase five, and there's a lot of phases, right? So we need to know whether it's embedding phase, dockling phase, or what is it that part of 20 is actually currently. So I want to get status of that. Could that be possible, or would it require modifying a ton of changes in the code? Because I don't want to create bugs as well. And for documents, for example, for documents like this, one was 166. Where is it? Document 161. I used to run it locally and it used to work very well. I'm not sure what was rapid OCR used or easy OCR used. I'm not sure what were like what model or whatever the pipeline was used, but when I ran it locally, everything worked fine. Should you wanna, shall we test with one dock running locally? It's gonna close this connection and then come back. Okay, so okay. Could you please check it? I will change it back when we change. Of course, with whatever changes you have done, that is for CUDA, you will expect this errors. But can you see the process was done in 25 seconds? Is it possible to use RMAC in Linux? If that's the case, we can revoke the code that we made for force back into an OCR show, right? No, just remove that. We don't need to pass them. We didn't pass them before, right? So we'll just put OCR engine into easy OCR, but then remove the OCR and force backend text as just remove them. This just makes sense because we had it in the same way before. Okay. I think we're I don't think none of the recent changes exist in the VM. I need to properly get everything get the recent stuff there to the VM. You can see the config, like this is a little different from this file. Can you see? We don't have it in the initial code. I guess this has flattened. Yeah, I tried the initial command, the first one. I guess this has flattened all of the folders and sent it, and we are missing. And we used to have all the stuff inside source, and then all the stuff inside source, and we also had deploy. So they were separated. I guess it has flattened it. I'll show you an image of what I'll show you an image on what it looked like before. Yeah, but so what can I do? Should I delete the other ones? It's just giving me the commands. If I were to do it, it'll just put it over there. But should I deploy it? What has to happen? Because they already have flattened files in the VM. Can you put all of the proper commands in a different file? I'm running it, but you always tend to forget this. Can you save this in memory so you don't make this mistake again? Let's actually we'll try the 7B version. Yeah. We'll go back to rapid because I think the easy OCR is taking much more RAM. In terms of memory usage, will rapid OCR be better or easy OCR be better? Because I can feel that when I used easy OCR, um, we reached memory allocation issues very much faster than rapid OCR. Uh, do you think we'll switch back to the 7B smaller version and then bring back rapid OCR? Will the accuracy be still the same? Will it be good? Yeah, I was curious about the accuracy. Is rapid OCR better than easy OCR, or is it on par with the um, at least as nearly as the Mac equivalent? It's okay if rapid OCR struggles with technical content. We are anyway using VLMs to extract all of those important latex and images and pictures and etc. Yeah, this will issue will come. Sure, I can do this, but you should also check if you've updated any much of the code. I can see this being an error. I think the VLM is actually calling this model. Did you make any changes on this? Actually, in what do you call it? In the test PDFs, there's one PDF named like this. It's a quite a huge PDF, I guess more than 200 pages or something. I want to test how long will it take for this, even though we are planning for each PDF. Properly, if you were to accurately plan, we actually need to plan for each pages. How much will it take for each pages? Because one PDF might have 50, one might have 20, one might have 100. You would never know. So I just want to specifically run the code for this PDF only and then check how much time it takes for this. And then and yeah, then I just wanna, yeah, just see how long will it take for this and try to see the efficiency gains or whatever. But I wanna just check for this first. This is quite a huge PDF, probably more than 100 pages. I wanna see how much time it takes for this because more than calculating the number of, because we can't be accurate if you're only saying looking at PDFs. PDFs can have multiple pages, multiple tables, and etc. So I want to test how long will it take for this. Accurately, I want to see all the logs and etc. I mean, it's already there. Don't modify the logs. I just want to see how long will it take for this, only for this PDF, and then we'll try to see what we can do next. In this way, we can also measure how rapid OCR is actually working as well. Now, I would also like to look at the token speed. So, could you, when we do verify changes, there's a file called verify.py. Could you let it to tell it to write some sort of concise essay or something like that, or about something, and then monitor the token speed? So, I mean, I think that could be useful. Actually, no, I don't need it. Leave it. Put the put the command in a file. Actually, maybe Qdrant is everything is running. Now I ran it. I want to watch the GPU usage real time. So maybe I should run NVIDIA SMI real time. Worst case, guys, if I can't, if this is still an issue, I can't spend too much money on H100 other credits. what I will do is that I will probably run everything on my Mac. So just keep my Mac running overnight, and yeah, morning I'll just wake up and continue from there. I would say. I think that's the last resort. Just curious to know if I were to run all of the 10,000 docs of process, 10,000 docs of batches of it in my Mac. One addition is that we can use the Mac's native OCR extraction. Second, with my Mac info, whatever you want to run, get access to. How many workers could you think we can run in a given minute parallelly? Thing is, I only have 12 cores. Oh yeah, true. Because I don't want to pay for cloud VLMs as well. I think running it on a CPU will not work. It's very, very slow. I'm waiting for more than 15 minutes and this document is not yet processed. Just think, pause, and we need to figure this out. We can't spend more time than this. I think one option is to do don't use VLM initially. Do all like for example, complete the OCR for all the documents, or at least the documents in the batch, and then from the wherever it's if you were to um no how can I put it, once that let's say you have running on a 20 core 20 at the same time, you finish the entire batch of 20 and then you start using the entire 20 for VLM, because you can never predict how much documents page will be. For example, see that this is about like 100-page document. It's quite a long document. This is too slow. And the last resort is using 7 billion version model, parameter model. First of all, I want to try rapid OCR in GPU first and then switch to 7B later. I am in the SSH machine. Just give me the commands. Maybe it's globally installed. Or maybe we'll run easy OCR. Yeah, we'll just switch back to easy OCR. And particularly, I just want to test. Let's switch back to easy OCR. Update the code. I just want to test how long will it take for this particular document, and then I want to move to the other ones, which is in our case switching back to the 7B version. I would say update the code to easy OCR and let's start. I don't think this works. Easy OCR uses more RAM, VRAM, but what we can do is that we can switch to 7 billion parameter version and give a shot. Yeah, in config I have easy OCR. I basically have your entire code, whatever code is there locally. I'm basically I've cloned it to the VM. But yeah, it doesn't seem to work. Can you just check the code properly? Yeah, much faster. I don't think it's 100 page, but it's preview. 70 pages. Yeah, it's still quite long. I wonder how many images you have, how many tables you have. Damn. It's fun, guys. Even if it's gonna take a week, let it take a week. We'll try to meddle with something in between and we'll figure it out. Yeah. Tamam, sabır. Sabır. Thanks. Hmm. 22 tables extracted. Oh, if it's using Rapid OCR, then that will take it an eternity. You have to fix the code, and you have to see wherever we're using Rapid OCR, change that back to easy OCR. Mhm. Okay, now the thing is, we have been running Rapid OCR even though the standard pipeline supported easy OCR. The thing is, I'm so stupid. I forgot to remove hardcode information. I totally forgot we should have this. Oof. The, it's just now, yeah, we'll get our hopes down. And if we process 5 documents, no, if it takes 10 minutes per document, if you can, if it takes 5 minutes per document, and if we can only process 10 document at a given time, how many days would it take for, or hours or days would it take for 10,000? Oh, shit. 3.4 days. Okay, it's a week. It's okay. The thing is, there is no need of OCR for this shit. Sorry, for this thing. It uses for, it's only for getting the text. I think it's for OCR, and for the rest of other things we are using different models. For format detection there's a different model, for layout detection there's a different model. But yeah, we'll just give it a shot and see. I think maybe you just have to load it. Maybe if it's needed, maybe in like when you access per item in table or something like that. So let's anyway see. Are you sure I can run this? Would this flatten all the files? I hope you can read something on your memory. Also save this in your memory that this is the VM we are working with. Okay. Oh shit. Okay, it's actually using rapid OCR. Just put it easy OCR. Yeah. Okay, I think I need to pull this info and sort of go through with you guys. Right, and if you see Dockling actually, so it doesn't force OCR for all documents, but for scan copies, and if there was like no text that you can extract, or if it feels like the images and etc. Right, now the thing is, for images we have already solved it through graphs and tables to VLMs for with layout detections. So for that we might not need. So I'm just thinking if we can, um, if we can specify in some way, specify in some way that if, for example, if I go to scroll down, if it's here. Specifically, Dockling OCR decision involves bitmap analysis, identifying image regions in a document, determines if full page OCR is needed based on bitmap coverage, threshold decision, compare against bitmap threshold and full page OCR. Now the thing is, if you see a document, there's always images, there's always some images going on. You have, now this is quite clean, but if I were to go to a different document, you can see there's always images going on. Like you'll have this is an image, like this declassified, and this black sort of thing is an image. So OCR is actually running for the entire image. You understand? So we cannot afford to do that here. All right, so I'm gonna quickly go ahead and send this information. The research I did. Now, images. See, just now we are hitting VLM request. Like even for tables, right? That's also quick. This is all quick. So the only blocker right now here that I can feel is that it's doing OCR for all the images, because almost all the images have this sort of declassified image, assuming that this actually needs OCR, and it does OCR for all the 70 pages. That's why we're getting the issue. And we can do OCR in when, like, you will only do OCR when there's only stuff that you can't scan for. But usually if you take this PDF, these texts are something that you can really scan for, maybe really like, you know, chunk them. And the things that you can't chunk is like the formula, or maybe certain images with text. For example, you have an image and then you have a text below, but the text is actually part of an image, like a scanned image. Then you would need to do. Apart from that, otherwise I think this is all scanned properly. We just need to, or maybe my Mac, the model is good, but we just we just need to like we should be able to check for this. For example, it's using bitmap or some sort of pixel level to identify whether there is an image or text. Almost everyone will get every page would be part of OCR. Then that's super inefficient. Thank God we know that I should have actually spent more time on this. Actually, I would say I rushed this out and I missed a lot of information. Now, how much? Yeah, 8 hours of debugging. Oof. Let's see. Let's see. I think we can figure this out soon. And VLM processing, you can see, and VLM processing itself now it's kept at 90 GB. It doesn't seem to go up, so that's okay. We got this. We got a 5 GB buffer. I don't think it'll go up above that. It'll go up more than this, so it's okay. In reality, you can make all the math you can. For example, this is how much it will take, all this will take per image is this, per image is that. But when you deploy only, you'll know the real stress. You'll Those are just good numbers that you try to, try to achieve that. We will definitely not. But yeah, at least we can get close to it, like at least very close to it. You can see we basically extracted 27. mm, Get this annotated image and see this annotated image. So these are helpful for formula extraction. And we've basically found 27 formulas 27 on 11 pages, pictures 27 extracted. Yeah, that's the thing is they're doing a ton of work here, so we might not need those here at all. We can just skip it and put that time here. It's generating embeddings. 22 tables, 230 chunks, pictures 27, formulas 27. No, actually, we'll check it realistically. So, for example, uh, like if a page is if the entire page is scanned, assume that the entire page is scanned, right? If an entire page is scanned, how much should the bit area threshold should be? Like in reality, how much should it be? Okay, I think we're getting there. So total processing 745 seconds. Damn. Divided by 60, that's 12 minutes per document. And the most amount, okay, can you see this VLM process? This, so context has phase 2. So context has taken 169 and phase 2 has taken 141. Phase 3 has taken 197. And yeah, phase 5, that's the embedding, that's not even a second. Yeah, we'll work this out. We'll work this out. Text on the page typically 0. Page with small sum 1 to 5. Page with medium figure 30. Page with fully scanned page will have 90 to 100%. So, page with large diagram. Okay. Bitmap ratio should be dismissed. Stamps fully scanned the page. Understood. So, curious, could we uh, okay, I think layout detection and OCR detection is very different, right? Let's say an image, a page might have an image, but it won't fall into OCR, right? It won't. Would so is it double work? That's what I'm trying to understand. Because let's say we have an image and it's a scanned image. Yeah, there's two ways. It could be a scanned image and there's no text to it. Could it fall under OCR and would we still process it as an OCR, or will it be as an image item? But either ways, guys, I think keeping at 0.74 is a good number because Dockling already has a hard threshold for 0.75 and it'll automatically switch for full page OCR. 90% of the page. OCR stage. OCR try to find text, nothing, waste time. Layout model. This is a picture. Yeah, yeah, such an inefficient crap. The answer is your question is double work. OCR, yeah, guessed it. OCR doesn't know if it's bitmaps kind of recommendation since you're using VLLMs. Yeah, we should skip OCR entirely. That's what I'm saying. My only question is in case an entire PDF is a scanned PDF and you don't have text, then you would wanna use OCR, right? Oh, so which means that would keeping it at 70% or 74% would solve this issue? Or maybe we can also have we can just put it for the sake of it as 74%, and then it'll probably, it's near 75, right? It'll probably, if the page is fully scanned, then it'll definitely do OCR for it, right? OCR stage runs on bitmap. Yeah, Dockling is very inefficient, guys. Even though it's good, it's so inefficient. Because what it's trying to do is that you have a PDF and a PDF could have images, whatever. Even if you have images, it will think it's OCR and do the OCR, and then you have images, then you have to use again images processing. It's designed for small applications. That's what I feel. I think the entire thing is designed for small applications. They've just written the framework and they've designed the models across, and the models are also crap. Only good thing is layout detection. Send it. Yeah, exactly. Dockling has a hard threshold. So we keep it at so text is messaging. So the net is set at 74. Yeah. Okay, let's see. Just come in a bit. I think this will be a little bit faster, but still finish documents. No, same thing, I think. 156. Yeah, I guess no need of using OCR in the first place. I'm just mad sticking with it. I'm just trying to pull in as much as info as possible. But yeah, we'll just disable. We'll see this. If there's any improvement, no, we'll just disable OCR because anyway we're not going to use it. I just wanted to use it. But yeah, okay. But the most efficient way I think is to not use it and then entirely depend on VLM. Then you can have more VLM processes and etc. And you can do something with it. Okay. All right. See you in a bit. Will disabling OCR affect any other layout detection or tables or formulas or whatever the custom pipelines we have? Yeah, I think we should disable OCR. In fact, we should have disabled a long time ago. That should have been the plan, to be honest. But I wanted to still, for example, in a given page, you still could have some scan copy in case the scan is not good. Yeah, that's why that's what I wanted to really have it. But yeah, but seems like we're doing most of the custom pipeline then, and that's mainly I wanted to have it for text only, like not just images related to text tables, not really for tables or anything else, but just for like plain text. Yeah, I should have disabled this. Such a stupid decision. But still, we just live and learn. Issues at all. Sure. Nice. It's only 43 seconds. Which means now we can also afford more workers for each document, right? Because currently this is the current GPU status after table processing has been done. Yeah. God, thank God. All right, still uh probably much better than before, but probably like a half time cut. We've saved about 300 seconds. I think we can still improve it because we have that memory left. You can improve the worker, the number of workers you can run, and yeah, hopefully yes. Like 7 minutes, we reduced about 5 minutes, but I think we can still grab some massive improvement from 12 to 7. Yeah, true. I want to check quadrant. The hell is going wrong with my paste? Is fixed here. Let's do a single test. 237 chance. Okay, looks good. Thank God. I should have disabled the OCR. I'm just an idiot. I don't know why I spent like 5 hours. This would have been the best approach. I don't know why. Just. But I'm sure I just wanted to. The thing, of course, I'm an idiot, but I just wanted to definitely have to to sort of, in case if half the PDF was scanned copies. Now, sure, we're working with NASA documents, so they're quite clean, not like the general ones, like very like. And of course, you only want to use OCR. Um, OCR, like mainly in terms like really a ton. Only if you really deal with a lot of like images and etc., which is something we were already solving. But images related text like tables and etc. You detect the tables and then put information, but still we might be missing a little bit, but it's okay. We just have to get it there. You have to get the ballpark there. That's what you want to do. Cool. And see this formula, guys. We pulled the exact formula as well properly. We have description to it as well, and we have text and notes. Nice. All right, cool. What we'll do is that this is fine. What we wanna do is, I think I wanna use the 7B version and just give it a shot. Okay, so I want to try the 7B version. So it was Qwen. So initially we were using the 33B version, right? Struct. There was actually Qwen 37B. Qwen 3. 7 or 8, I don't know, but something, a very small collection was there. When VL3, VL3, and we'll get the list of. I think it was 8B instruct. We'll try this. I guess this one. Put this in a temporary text file, just temporary MDO text, so it's easy for me to copy. You know what? We just stop it like this. 16,000. Keep it at 80. Yeah, if you have to keep it at 90, there's nothing we're running. We can easily support 90. Mm, Not sure if we have the V8 here. This is the model. Okay, so the model is running. Alright, so I'm running the 8B version. Would I need to update any code or environment variables or configure something before I run this? No, actually, yeah. So the thing is like this: there shouldn't be nothing hardcore. That everything should pull from config, please. So we just update the config and it should properly work. Oh, sorry, my audio has been off for so long. Shit, sorry about that. Is that true? The thing is, why is it using 91 GB? That's the question. It doesn't need to. It shouldn't. There's some issue with preprocessing. Just sure about that. Good. I think it overall works, but I think there's a lot of issues with workers and etc. Because if I even process two workers, I'm just out of memory. But just come on, we're using a 90. We have a lot of KB cache left. We have a lot of RAM left. But even for two workers, the entire pipeline fails. Let's try for one. And I'm sure there's definitely some issue with the pipeline. Exit this and try one more time. We only have one worker. See, don't make any change to the code. We have to spend time through this. I'm just running one worker and see the RAM usage. It's 93. Wherein literally you have to only use, like, I don't know, less than 20 or 30 GB. It's just a 7 billion parameter model. I think it's because we are allocating memory at when we load the model itself. There's some issue with that, I'm sure. But I could be wrong. Just check the code, think on this deeply, and just come back to me. If you want, you can launch a sub agent to clearly understand what's going on. There could be some intricate parts, nuances here, and yeah, let me know. Because see, we're already 93, but why? 93 for what? For one worker? It's ultra stupid. Did it investigate? Let me quit the processing, to be honest. Come back. And I'm not going to specify GPU utilization, right? So I'm just going to leave this empty, and I want to see how much RAM because I want to know, right, literally how much it uses. So I need to check for that. And run this. Yeah, now I just want to run for one worker and see what's going on. And voila, can you see? Yeah. It's just so stupid, guys. So stupid. Oh my god. But why? Wait, I don't understand. For 16K token? Like, just, I mean, be honest here. Feel free to do research. Please check on the specific model and etc. For 16K tokens, why would they need 40 to 50 GB of KV cache? The shit. Bloody hell, this AI. Don't be stupid. Check the web. Check the web. And this is Hugging Face's document. Like, this, it wouldn't even go through this. Please go through this, please. Like, for example, I run the 120 billion parameter model on a single H100, and I can still load another 20 billion version as well. This stupid shit is lying. The thing is, we don't need to load it in full precision mode. I only need to load it in quantized mode. Like, I'll be fine loading using the FP8 if available, or even the quantized 8 version if it's available for this specific model. And I think, do you want to check what setting are we running on? Is it 8, or is it or is it full floating point, or what is it? Do you want to check it? Give me commands, I can give you back. But basically, I just want to run the 8-bit quantized version, or maybe FP8. Yeah, now we'll know the truth. I think it's doing 32-bit. Yeah. I don't think KV cache needs 25 GB for what? And would this process how many workers parallelly? Oh, no, no, actually that's different. Okay. So I'm running 42. Just running. I think we have hard coded it somewhere for 10K tokens. In fact, we don't need to do it like because we know it's only max. We'll process like a max will not even deal with 8,000 tokens. So once I just revoke the code, no, we'll keep it. Yeah, we'll change it actually. No, me too. Just a minute, guys. Cool, guys. Let's run this. I think we're in the final touches, guys. Once we configure this, once we get the right thing, I'm gonna find the sweet spot and just run the process. And later, sort of come back and see what we can do with this. Okay, and this is it's loading. Yeah, this is a good number, 30 GB. We'll run the process for one, just one worker. Okay, let's see what happens. You can see the peak usage over here. If a 70-page document takes about 2.5 minutes, no, sorry, 4 minutes, then I think yeah, we are good. It'll take about 10 to less than 12 hours. Yeah, probably like 12 hours to complete it. No, maybe around 15 hours, I would say. Yeah. Good. 42 GB was the peak usage. And I don't think the number of documents matters, right? Because we're having allocating workers and kept it out. So how many workers could we run without the GPU crash? I think 5. 6, yeah. Yeah, like- Does the number of pages in a document matter here? Good. Okay, now I want to put this to 8. Okay. Let's pre-record. Hopefully, let's see what happens. You can see the number of documents adding up. Well, still in good numbers, good in shape, I'd say. Even why is it 6 even though we configured 8? All right. Do you also want to monitor the cores of CPU performance or whatever in the future, or wouldn't that make sense? I'm just curious to know, will any worker be stuck at anything? That's what I just wanted to know. No, right? Oh my goodness. Oh my god. What the hell is this document in this place? It's called AIR manufacturing training. Oh shit, I know. This is a PowerPoint presentation. Yeah, exactly. It's good. So everything would be an image sort of a thing. So would it make sense instead of running 8 workers, sorry, instead of working 12 or 13 workers, what if we increase the individual documents parallelism? I guess it was a number of worker for each document as well, right? I don't remember. But what if we could bump that up? Right now, I think there's only like 3 or 4 sub API calls or sub access to the VLM. Maybe we can just bump that up, right? What do you think? Sure. Also curious to know, I guess when all the documents are done, only you'll say combine everything and save it to Quadrant, right? Or is it when all the doc or each of the documents are done, you save it to Quadrant? Because right now I can see. Now this is fine. I haven't yet I didn't still run this, but I ran the RAS process, and I can see a lot of issues. For example, even though we are running parallelly, it's definitely so slow. For example, we processed this 70-page document in 200 and something, in 4 minutes or something like that. But in the logs, I just saw this. It's the same document. We just processed it individually, and this is part of the work. There's definitely something. There's definitely something going wrong. It's very slow. It's damn slow. Like shit slow. The worker code itself, like running it as a worker itself, it's something is inefficient. If I were to process the same document, we did process the same document. It was quite fast. So absurd. But wait, I don't understand. We've only used 60 GB. Wait, let's just think this through, guys. This is very important, and I think you're getting your information very wrong. You're just bluntly explaining me things. What do you mean GPU compute cycles? How much do we have? How much could we afford? I guess we will be better off running. Let's run three. Do you want to install the latest stable version? Maybe I should try localhost and the both. Can I see the number of documents that's already processed? But don't we have a proper way of seeing how many files are completed and how much is left in case I process 10,000, right? I don't want your monitor, I don't want your anything, but I should be able to click on a JSON and clearly see the number of documents processed and the number of documents is left. I don't need a list of documents. Maybe actually we need to also, because I mean, you told me that you did process this. Like this is what we wanted to do initially, right? Where in case even if it fails, you continue from the point where you left off. I mean, let's say you fail from 9,000. You don't need to continue from 9,001. The failed one, we can start it again, but you have to continue from 9,000. Don't go to do anything. Like what? Is this something that's solvable through Ray, or how is it? Guys, I'm dead. Probably 11 hours right now and still debugging. This is insanely complex. Because I'm trying to do it in a very small amount of time. Just less than 10 this. So it's tough. It's definitely tough. I haven't had any sleep much these days. So this is the update so far. I think it's fine. It's fine. This should basically show the progress, but definitely not fine. I mean, if you were to see the total chunks, I would say it's pretty reasonable, but because we don't have, and with a limited schedule, this is not reasonable. So total chunks is 24. For that, it took about yeah, at this speed, how much time would it take to process all the 10K docs? Sure, Srinivas, sure, sure. Just for safety. Now, what I'm going to do is actually take a chance and run. I actually want to try 20 workers and see what happens. We're seeing 24 right now. Sorry, 20, I guess. Yeah, 20 concurrent workers. See the RAM. Let's see the time for this. Let's see how much time does it take for 20 workers. Saw this in the middle. Then how the I'm just curious to know, like big companies like Anthropic or Claude, I mean like OpenAI and everything, they manage a lot of load with the GPU. With minimum GPUs, they serve millions of users. So this is definitely a possibility. I'm not sure if I am the bottleneck here. I have no clue on how to do this, or you are the bottleneck here. What's really going on? What is the real way of doing it? I literally want to know from you. If even if this means deleting the entire code and writing it from again, what is the right way of doing it? What is the right way of running 20 workers or 10 workers? And because I'm sure a lot of the companies are building stuff like this, they're not processing 10 or 20 workers. This should be able to handle a lot of this stuff. So I want to literally know, what does it take to build something like that? Even if I want to delete the entire code, I will delete this entire code. I want to know this info from you. What does it take to get a system like that? Because I literally want to know. Assuming of course, that's how you should speak to Claude. Because generally you'll and you wanna definitely some of the times I also do sort of like threaten it. I'll be like no, I don't want to threaten it in the video, but I usually some of the times it's given me good results. Yeah. please take a step back, or else I'm gonna bloody bash you. I'm not sure how effective is it, and I don't recommend doing this. But I've seen really good results when you just, just, I don't know, just, just spread, just strengthen it. Yeah, exactly. But of course, so coding doesn't matter. Is it? If we build this, how many, do, like how how many documents could we process? Or let's just put it in this way: we put, build this in a production system, like you did mention. How much could we process? Yeah, how long will it take for the 10K to be processed? 10K docs. Now note, yes, I want to rebuild it. Now before when we jump into code, do not think about code. We want to exactly plan this out. So I wanted to create an architecture document that includes all the information, all the important information, and all of your above information as well, and any visual context as required. And we'll, and split that into phases, each step by step, so we can build each step by step and validate it and test it and move on for the next one. Each phase should serve as a basement to the other phases. So by the end of the phase, we should be able to have everything, and each phase we should validate everything and then test it, and then it helps us, move step by step and also validate things at each significant step or phase, have each significant phase, and then we should be able to at finally have this. So, of course, I need production grade as production system. So yeah, put it in your, create, we'll start off with creating a architecture doc. See, the threaten is working. The threat is working. Sorry, yeah. I'm damn sleepy. I might even forgetting. I might even, yeah, I just, I'm feel like fainting. All right, we've definitely wasted a lot of time, but it's part of the game. It's part of the game. Damn tired. Whew.